Welcome to Personal Web Tutor. Today's problem is we've got a rifle and it's aimed horizontally at a target 50 meters away. The bullet hits the target 2 centimeters below the aim point. A. What was the bullet's flight time? And B. What was the bullet's speed as it left the barrel? So let's draw a picture here. We're going to draw where the rifle... So we've got this rifle. I guess my time in the Marine Corps it looks more like an AK-47. And we'll say the distance from here to this target is 50 meters. And we were aiming right here. But it hit right here. Aim, hit. And this distance, 2 centimeters. We've also got gravity. We're going to say gravity at G and 9.8 meters per second squared. So if we imagine this bullet coming out, the initial velocity we don't know, we're going to look for that later. But what I want it to notice is we're aiming for this point here, and so the round is actually going to fall a little bit. The reason why it falls this much is because of gravity. So gravity, during that time that the round goes from the rifle to the target, gravity makes it go down 2 centimeters. So we have the initial y0. We're just going to call this right here where it's aiming at, we're going to call that 0. And then we're going to have y final. When it hits this paper, this target, we're going to call that 2 centimeters, minus 2 centimeters. We'll just call it 2 centimeters. We're going to write it in meters, though. We know the acceleration, which is equal to g, is equal to 9.8 meters per second squared. Also, just to make clear, we're going to say that going down right here, we're going to say going down is positive. This way we know that it went down 2 centimeters. That's positive. So this is positive and this is positive. Now, we also want to remember that we're not worried about the velocity in this x direction, but the velocity in the y direction is what we want to worry about and think about. And so the initial velocity in the y direction over here before it gets fired is 0. It gets shot really fast, but the initial y direction, it doesn't get shot down. And so these two vectors are parallel, and vectors that are parallel do not affect each other. So lastly, we know that the velocity, the initial velocity in the y direction is equal to 0 meters per second. So we're going to write out our equation, and that's going to be equal to the y final is going to be equal to the y initial plus the velocity in the y initial times time plus 1/2 a in the y direction, and we know that a in the y direction is g, which is gravity. G times t squared. So right off the bat here, we have VOY is that's the initial velocity in the y direction is 0, which makes this 0, and it cancels out. And we also know the initial y is 0. So let's look. We are left with y final equals 1/2 gt squared. So we know y final is 0.02 meters. 0.02 meters is equal to 1/2. We had 9.8 meters per second squared t squared. So what I'm going to do is multiply both sides. Actually, let's just do the arithmetic on the right hand side. So this is going to be 4.9 meters per second squared times squared, and over here we still got our 0.02 meters. So now I'm going to divide by 4.9 meters per second squared on both sides. So I got 0.02 meters, and I'm going to take the reciprocal. So it's second squared over 4.9 meters is equal to t squared. And notice these meters cancel out. So we take 0.02 divided by 4.9 and take the square root of that, and we get t is equal to 0.063 seconds. Now, going back up to our problem, the other thing we want to find out is at what speed did it leave the barrel. Now that's a pretty easy question because G here, it does not affect the horizontal firing of the bullet, so we don't have to take that into consideration. However, we do have this time that it took that we just got. The time we got was 0.063, and we do have the displacement. We have x is equal to 50 meters. Time, of course, is in seconds. So we can use the simple equation v equals x over t. And so we do the arithmetic. And the answer that we get is 782.6 meters per second. If you have any questions about what we did here or about projectile motion, please feel free to go to our website at personalwebtutor.com. You can click here on Ask a Question, and it'll bring you to the site. Put your question in here, and you never know, your question might be my next video. Thank you.